So the question is two stable isotopes of lithium Li6 and lithium 7. Okay. So these two isotopes, so it is given, it have abundances of 7.5 percentage and 92.5 percentage. What is the meaning? That means 6 lithium. This is atomic number, this is mass number. So this 6 lithium, it is present in the earth only 7.5 percentage. This 7 lithium, that is the mass number of 7 lithium is present 92.5 percentage in earth. Okay, but the atomic number is same since it is an isotope, right? And then its isotope's mass also given. You are asked to find the atomic mass unit of lithium. So the formula will be isotopic masses into the abundances. Okay, that means suppose for example for lithium, let this be first atom and let this be second atom. So that means first isotope and second isotope. So plus M2 into A2 like this. You can take like this. I will explain from this solution. So mass of lithium isotope is given and then mass of lithium isotope 7 and 6. Okay. So the abundance is taken as some symbol. You can use any symbol for this. Okay. So the abundance, you can make it A1, A2 like that. So this is the formula. That means mass of the lithium 6, okay, into the abundance of the lithium plus mass of the lithium 7 into the abundance of the lithium 7 by the abundance total. Almost that will be 100%, right? So out of 100%, 7.5% is available only for lithium isotope of 7 and lithium isotope of 6 is 92.5 percentage. Okay, keep in your mind everything you have to multiply and then the resultant should be 6.940934 atomic mass unit. Okay, so this is the answer. Similarly, you're asked to find in this what? Boron has two stable isotopes, boron 10 and boron 11. Their respective masses are also given, and the atomic mass of boron also given. Find the abundances of these two isotopes. You are asked to find the abundances. So the missing will be the abundances. So let the abundance of the boron 10 will be X percentage means the abundance of boron 11 will be 100 minus X percentage. So out of 100 percentage of the uh, abundance means the appearance of this boron, the availability of the boron on the earth. Okay. So its abundancy on earth depends upon its availability. So out of 100%, we can take boron 10 as X percentage and boron 11 as 100 minus X percentage. So like the same formula you can apply. You are given atomic mass unit of boron, that is 10.811. That might be an average of the mass number. Since it is 10, right? The boron's mass number is 10 and the next isotope's mass number is 11. This atomic mass unit will be lies between 10 to 11, right? 10.811 like this. So this lies between these two mass number. Okay. So the X will be founder and 90.89 percentage. The boron 10 will be 90.89 percentage and boron 11 will be 80.11 percentage. Like that, you can easily calculate. Then the next one also given like this. So neon, three stable isotopes of neon, 20, 21 and 22, its abundance are given and then isotopic mass is also given. You're asked to find the average atomic mass of neon. So you are given three isotopes of neon. So for three isotopes of neon, the formula will become like this. So this is the formula. So keep going on this. And then this is an average atomic mass unit. Okay. Then next question is obtain the binding energy in million electron volt of nitrogen nucleus. Nitrogen 14.7. So the atomic mass unit also given. You're asked to find only the atomic mass unit is given. And then you know the mass number and the atomic number. You're asked to find the binding energy in million electron volt. That is the question. So how to answer this? So, students, you must listen. You have to write all these things when you are about to answer for this question. So, while you're writing, you need to write all these steps. Okay, this is very, very important in this aspect so that only you'll get the full marks. So, what is the atomic mass of nitrogen? It is given. Okay, the nucleus of nitrogen contains 7 protons and 7 neutrons. So, how you can find neutrons? Mass number minus atomic number. So A minus Z. That will be 14 minus 7. That is equal to 7 neutrons. Got it. So the mass defect of this nucleus will be this formula. That means delta M is the mass defect. Okay. The change in mass defect. So this will be the, it is given mass of the proton. So for mass of proton, you can take down like this. Since H plus is a proton, right? So, and then mass of a neutron can be taken like this. Okay. So what is the mass defect? This is the atomic mass unit. You are going to subtract. So this total mass taken from the nucleus. This is the nucleus mass. The mass of the whole nucleus. That is 7 neutron and 7 proton. So 7 into mass of a proton. This is the mass of a proton. This is the mass of atomic mass unit of a neutron. So these values will be given at the front page of a question paper. So don't worry about this value. It will be given. Okay. Otherwise, you will be given as a hint. So you should multiply 7 into this value and 7 into this value and minus atomic mass unit. This is the mass unit given. So this change will be the mass defect. You can easily find the change. Okay, this is 0.11. It will be very feeble. So 0.11237, atomic mass unit. But your answer is, you have to find the answer in million electron volt. So this is the equivalent atomic mass unit for million electron volt per c square. C is the speed of light. Okay. So per c square, the one 931.5 million electron volt is the one atomic mass unit. So you are given, you have the atomic, that means the mass defect as 0.11236 atomic mass unit. That is converted into million electron volt per c square by multiplying 931.5. So what is the binding energy? This is the binding energy. So based on the Einstein's mass energy relation, E is equal to mc square. So this is the binding energy, which is using the defect mass, okay, mass defect and speed of light. Everyone know the speed of light will be like this, c. So what they're trying to achieve, so this will be 0.11236 into 931.5 million electron volt by c square. Already c square will be there. So c square gets cancelled. The answer will be million electron volt. So don't extend your answer by substituting all these values for c is equal to 3 into 10 power 8 meter per second. Not like that. So keep in your mind c square will be coming in the energy relation, right? So you can cancel it easily. The result will be 104.66334 million electron volt. Got it? Then, so what is the next one? Iron and bismuth is given in million electron volt in data. It is okay. Okay. You are asked to find binding energy of iron and bismuth in million electron volt, the same as the previous one. Iron's atomic mass unit is given, and bismuth's atomic mass unit also given. And from this mass number and atomic number, you can easily find number of protons and number of neutrons. Right. So from this, you can easily find number of protons from the atomic number. Then, subtracting atomic number minus, sorry, mass number minus atomic number, you can easily find what? Neutron number. So what is the mass defect of the nucleus? So this will be, right? So number of protons into mass of proton, that means atomic mass unit of one proton. plus number of neutron into atomic mass unit of one neutron minus the given atomic mass unit. So you are going to multiply this. Don't worry about this value. It will be given on the front page of your question paper. So don't worry about this units. So you're perfectly, you need to practice how to calculate. So don't worry about the decimal points. First, you omit the decimal point, and then after the multiplication in the product, you can count the decimal and then put the decimal point. Okay. So keep multiplying each and every point. I mean, here you are given after the point, 6 digits are followed, right? So you have to use all the digits and then multiply. Then only you'll be getting the perfect answer. Okay, don't round of something. Okay, so if in this chapter you should concentrate on this calculation, very important. Focus on this calculation. Otherwise, you won't get the correct answer. And then this chapter is very important for numerical problems. Okay, so for doing all these kinds of problem, it may consume your timing. So you need to, students, all of you need to practice this. Then only you can quickly calculate all the numerical calculations. So plus and minus, everything you should keep in your mind. Even a simple, I mean, even a silly mistake, it leads to a wrong answer. Okay, so keep in your mind this thing. So you can find easily the delta M. After finding the delta M, you can convert that atomic mass unit. So everything is an atomic mass unit. You can convert atomic mass unit into million electron volt per c square. So as per the previous one, and then the binding energy will be delta M into c square. So c square gets cancelled, and the average binding energy per nucleon is given. So for bismuth also, like the same way, you can follow the procedure and do for bismuth. So take this as a homework. Okay, all of it take down. So bismuth, what is the mass number given? 209. And what is the atomic number? 83. Out of it, you can easily find the proton number and the neutron number. So based on that, you can easily find the mass difference. I'll give you the flow chart right now. First of all, keep in your mind like this. First, from the atomic number, you are going to find, from the atomic number, you are going to find what? You are going to find proton number. And then by calculating the mass number minus atomic number, so where the mass number will be and the atomic number, so the mass number is at the top and the atomic number is at the bottom, like this. So you'll be getting the neutron number. Okay. So after getting neutron number, what you need to find? You need to find mass defect. So what is mass defect? Delta M. Delta M is equal to the number of protons, that is number of protons into mass of the proton, okay, plus number of neutrons into mass of the neutron. This atomic mass, again and again, I'm saying, repeatedly saying, the mass of a proton and the mass of a neutron will be given at the front page of your question paper. So don't worry about that. Okay, plus, and then this atomic mass unit is given, so you have to subtract from that. Okay, so this will be the delta M, and from this, to find the binding energy, you have to use the Einstein's relation, that is delta M into c square. And don't forget to convert in between. You have to, if the answer will be in atomic mass unit, you should convert that into million electron volt by multiplying 931 million electron volt per c square. Got it? Okay, is it clear for you? Okay. Then EB, you have to substitute the delta M value in terms of this million electron volt per c square. This c square and this c square gets cancelled. No need of substituting the value of the speed of light. Okay. This will get cancelled. So you'll be directly getting the value of binding energy. So this is the, flow chart, which is very useful for you to find this kind of problem, okay, to find the binding energy of a given nuclei. Okay, so any nuclei, for any nuclei, you can easily find the binding energy by following this method. So, students, you have to follow this kind of flow chart. Okay, so do follow our videos to learn properly, okay, in a problem solving. Okay, this type of flow chart will give you a problem solving skill. Okay, you can develop it to next level. Okay, thank you.
Why don't you